Welcome everybody. So my name is John Yu, and I work for Genscript. This afternoon, we will take a look at some of the work we have done in order to make the Western blotting process faster and through a number of small devices to speed up the process. So maybe let's set up the question first. So as many of us study proteins, we have different ways to analyze proteins. Here list some of the most common ones like Western blotting, SDS page, immunohisto, and then ELISA, and then flow cytometry, and so of all of these, one of the most classic and then probably most commonly used one is the Western blot. However, it's been many years since this process has been set up, and then it hasn't really changed that much, right? So the question is, are these methods still good, and are they still suitable for what we have now? And we have more and more work to do, and we need more and more data. And do we still want to use the same process that set up many years ago? So just to use illustration, it's not a strictly, we didn't do any like strict statistics, but just to illustrate the issue that we're facing now, if you look at a paper from about 2000 from the journal Cell, and you see there is a workflow, and there is a Western blot of the separation, and then some characterization. So it's fairly straightforward with some simple illustration of the purification process. You can get a good paper. And let's look at about 20 years later in the same journal Cell, and this is a study of regulatory factor. And as you can see, there are many more factors we need to look at, and then also oftentimes we need to get need the quantification information. So that basically means for the same publication or for the same question we ask, we need to do a lot more to get to the answer or get to the publication. So now, if we still follow the process that's been set up, decades ago, so there's so many steps in this overall process, it'll take us at least a day to complete the work. Now, can we actually do this a bit faster? So if we look at a typical Western blotting day, there's a few major steps if we just quickly go over them. First, of course, you need to have the sample ready, and we won't get into the sample preparation, but there's actually a lot of question there as well. Maybe we'll cover that in the future. Then first we'll have to do is the SDS page separation. And then we transfer the protein onto a type of membrane, either it's PVDF or NC. And then we develop the membrane by incubating it with different antibodies and wash it many times. And in the final step, we do an imaging step with either chemiluminescence or with fluorescence. So time-wise, if we make our own gels, and it'll take about 3 hours for the SDS page, about 2 hours to set up the protein transfer. And then the longest step is the incubation, which in total approximately will take about 5 hours. And then so if you sum these all the time together, it'll be about 10 hours. So if you ever done a Western blot, then you know that it's a very long process. And then of all this, many things can go wrong, especially if you make your own reagents. So in Genscript, we want to make research easy. So we attack each of these steps, and we developed a number of small devices. The first one I'd like to introduce to you is the Easy West, which is for the incubation step. We just released it this year. So we're aiming to use it to automate the membrane incubation step, and then eventually to reduce the time that's needed for this particular step. So here shows a picture of the EasyWest Lite. It's a small device. It'll fit on any benchtop. So here's some basic features of the device. We call this EasyWest Lite. Well, from the name, you can guess that there's another version coming, which will provide more capabilities. And so this device is fully automated, and you can finish the incubation once you set up the device, and it'll do everything for you. And as so long as it's done in this device, the result can be consistent because many of the manual errors will not happen. One of the common themes we face is that after a while, we lose track of how many times we've done certain things. Because between each step, you need to wash the membrane a few times, right? So sometimes you forgot to go back. Sometimes you wash it too few times. Then the result can be variable. And then also these devices can save antibody as well. For each antibody, you need about 10 mils, but these antibody can be recovered and then can be reused for as many times as it allows. And this device is very flexible. So for using the EasyWest, you do not have to have a special reagent, although we do plan to launch another reagent soon. That's for a different purpose. I'll cover it later. But you can also use the reagent that you have already in your lab. You do not have to buy anything special. So this is what you call open platform. There's no proprietary reagent, so you can use everything that's already in your lab. So some numbers to give you the capability of this device. So it's suitable for one set of antibodies, one primary and one secondary antibody. And it can fit at most 2 membranes. And it can also be compatible to the strips if you do a smaller number of comparisons. And it's compatible to gels, mini gel size. So we do have plans to have a mini gel size as well, but that's not ready to be launched yet. And so for each antibody, you need about 9 mils, and the antibody can be recovered. So for consumable, we do not have anything that's restricting, and you can use your own reagent. And then you can recycle the antibody, and then the performance is very consistent. Just to illustrate how this device works, you have basically 2 parts. One is the device, another what we call cassette. So the cassette is where you hold your membrane, and the device will have 3 slots for your primary antibody, your secondary antibody, and then the blocking reagent. To set up the membrane, you need to open up the cassette, and you lay your membrane onto the cassette with the protein side facing up, and put on a spacer, which keeps the membrane from floating away. And then you close the cassette. Once you close it, you can load it into the EasyWest device, set up the program, and then once you click start, you can walk away. So it'll take anywhere from 2 hours to about 4 hours to finish, depending on the program that you use. And during that few hours, you can take your time to read some papers or maybe just take a break. So some results to illustrate, and these are done in our labs to compare the conventional result versus the EasyWest Lite. And as you can see that both have been repeated 2 times just to compare if it's consistent. And as you can see, it's very comparable for a common household protein gap gauge. And for EGFR, similar results, and it's very comparable and it's consistent between the different trials. And then we also attack something a bit harder, which is the VDAC1, as this antibody is a bit weaker, and we'll still be able to get pretty good consistent results here. We also have tested this device into different labs. This test has done in a lab in the US, and we've compared the manual protocol and then EasyWest Lite protocol. As you can see, that actually we got better results from the EasyWest Lite, and that's partly probably because that many of the manual steps have been removed, and then any inconsistencies can be removed from the Western blot process. Now, just to summarize, this is the automated device that can complete all the blocking, incubation, and washing steps. So you do not have to worry about every 5 minutes you have to go back and change your solutions. And so it works by actively circulating the solution into onto the membrane. And I think the best feature of this device is that it's an open platform. We do not want to lock you onto any kind of reagents. We do not have mandatory proprietary consumables. And it's a small device. It's only about 20 centimeters each dimension. So it's a small device, can fit on any kind of benchtop. So if you feel that the current incubation is taking too much of your energy, then maybe you can give it a try. So we're also looking to release EasyWest diluent. So this diluent is used as both antibody dilution solution and also a blocking reagent. So with this diluent, we can reduce the incubation time. Preliminarily, our tests have shown that we can cut down the time to about half of the time we need right now. So in combination with the reagent and then the EasyWest Lite, we can cut down the incubation to about 2 hours. And then that should shorten our day to about 7 hours, which is within the 8-hour working hour per day, right? So that's good. But then we would want it to be more efficient. So now let's look at protein transfer. So protein transfer is also a very, variable step where it can determine the results, but at the same time, every time you do it, there might be some difference. So conventionally, we have the wet transfer. The wet transfer, of course, is the golden standard, and it's very good in transfer efficiency. But the setup is very, I would say messy, and also the process is time consuming. So sometimes it can take about 2 hours, and sometimes it will take a lot longer, even overnight. So it's not very convenient. And so that's why on the market, you'll also see some semi-dry method. And the semi-dry method is good because it's fast and convenient. But at the same time, you are trading the convenience for something with something else. Because semi-dry transfer often would have trouble transfer larger proteins. Something that's above, I would say, 100 kD, you have a chance that you won't transfer as efficiently as in the wet transfer. Now, what if we can actually combine the two? That we have the good transfer efficiency, but at the same time, we would be able to transfer the larger proteins more efficiently. And here we have the unique fast wet transfer device, the eBlot L1. So this is fully developed by Genscript, and we hold the IPs for the device. And this is, is a device that does the fast wet transfer. So the transfer is actually based on the principle of the same principle as the wet transfer, but we just tweak the solution and then also build the device to speed the process up. So we can speed up the transfer from a few hours to now only take about 9 to 17 minutes. A typical transfer on eBlot is about 12 minutes. So you can get a good transfer during that time, and it's very easy to assemble. And once you set up the program, you just press the button and it'll get done in about 10, 20 minutes, including the setup time. So, and then the device is programmable. Now, some results that we get in our lab, so compare the wet transfer to eBlot L1, they're very comparable. And some might even say that eBlot give you a bit better results. Here are some more comparisons with some of the other semi-dry device on the market, where you can see that a lot of times when you get to the larger proteins, and that's where the difference show. So with wet transfer, you can do a good job with EGFR and with eBlot as well. But for some of the other semi-dry device, you see that the transfer efficiency goes down. For a regular protein, something like GAPDH, so that's okay. Now, with the eBlot, we actually have been introducing this device for a few years, and it actually get a lot of good receptions. And this is one of the stories that we have encountered during the process, and I think it's a good story to share, and just to tell you why this is a unique device. So the title give a lot of it away. So we have this professor. He works in a university in Florida. So I wouldn't share any particular details of personal details, but then he's working on something that's very unique. Its uniqueness is in that it's a very large protein complexes. You have a protein complex that's made up of 3 different subunits, and so he's running it on the native condition, and so the complex would end up about 1200 kD, which is way above what we usually do. So he wanted to do Western blot on this complex, and he wanted to do it, with the conventional wet transfer, and he wasn't successful. So he turned to almost all the devices on the market. Any of the semi-dry transfer he has tried, and he just couldn't get consistent results. And a few years back, and he eventually on one of the convention, he saw one of the eBlot device that we were exhibiting, and he's immediately interested, and he wanted to do a demo. And so we gave him a device, and he demoed it, and he saw some results that's actually encouraging. And of course, because this complex is so large, he couldn't use the standard program to do the transfer efficiently. And so we worked with him. We optimized the protocol. We added a few extra steps to ensure that the large complex can be transferred efficiently. After which, and this is the result he got, you can actually transfer a 1200 kD protein from a gel to the membrane, where you can get a good Western blot results. And I think this just shows that the uniqueness of the eBlot L1 device. So with the eBlot L1, it's the fast wet transfer device. Then we can not only keep the transfer efficiency, we can also reduce the transfer time to about 20% of before, well, actually 30%. So it's about 10 minutes, so 0.2 hours. So with that, we can reduce the overall time for Western blot to about 5 hours. But there's still room to improve, right? So now, finally, we look at the gels that we use. We typically, for our own gels, I used to do that myself, but then again, we moved to the precast gels. So one of the best feature of the precast gels is that it's more consistent, and it's very stable in a lot of ways. For the Genscript gel that we have, it's on the neutral buffer system, and because of this, then it can last a lot longer, and you can keep it around for about a year in your refrigerator, and then you can run it at a very high voltage. The gels from Genscript can be run at 200 volts, and that reduces the electrophoresis time. Typically, you probably would run it for about an hour. Now you only need it, only most half of the time. Okay, and it provides good resolution. And I think one of the most unique features of the Genscript gels is that we actually build the wells differently. So we have the wells enlarged on the top, where on top we have a larger space between the two plates, which means with the same line width, then you can load more proteins or samples onto each of the well. And so for our gels, the largest loading volume would be 80 microliters. So which is kind of convenient if you have a dilute sample that you want to separate. So we cover the most common ranges, and so typically the recommendation is just use one of the gradient gels, and so here shows the running time, and so the shortest is about 18 minutes, but of course you don't always want an 8% gel. If you run any of the gradient gel, you can finish it in somewhere between 20 minutes to 30 minutes. And also we offer different buffer system, like some of the other precast gels. The MOPS and then MES buffer can suit different protein separations. For a typical larger protein separation, you want to use the MOPS, and then MES is better for the smaller proteins that's somewhere a bit below 30 kD. And the resolution, to compare the resolution of each of the gels, and also with the homemade gels. As you can see, of the homemade gels, there's a bit of a blurry, and this is not because the picture wasn't taken properly. This is because the separation and the resolution is slightly different. Okay, and the same actually goes for this is the homemade gel, and then there's the a couple of competitor gels that you see on the market. All of these gels, and you probably can tell that the Genscript gel and then also the competitor D gel is probably give you the best resolution, and Genscript gels in this particular case shows up a little better. Okay, and we also recommend to use the LDS buffer, even if you use the homemade gels, and because that give you a better sample preparation. And this enlarged portion from the gel shows you the difference that the LDS buffer makes. Okay, so before you use the standard laminate buffer, you have the different proteins still connecting together, and once you switch to LDS, you have a better separation. Okay, so the main goal to use the precast gels, of course, is to be more efficient, and you can further reduce the overall process to cut down another an hour and a half. And so that will give you about a 3-hour for Western blot. And that's half a day. And you can finish your results and then decide what to do next in the afternoon. So before we move to summary, I think I'd like to introduce you to also another different device. This device looks very similar to eBlot, but it's blue in color instead of the green. And so this is the eStan L1. They share a common look, but then it does something else. So this is a fast stain device, and they can stain SDS page gel in about 10 minutes. And it's fully automated and very sensitive in terms of detection sensitivity. So it can detect protein as low as about 12 nanograms, and very efficient. And so just to compare the eStain device with the regular staining, and if you use a regular staining, then typically you'll stain for about an hour and 2 hours, and then you leave it in destain for a long time. And 2 to 4 hours is a typical time, but then usually you leave it there forever, right? So can take a while before you know the results. With eStan, this is actually much faster. You just need to set it up and then run it for about 10 minutes. So the total time is about 10 minutes. If you have some results that you're really eager to see, then I think this device suits that needs, and it's very consistent. So, and here shows some of the results. And this, the left-hand side shows the sensitivity. And for any of the protein band that's above 12 nanograms, you'll be able to see it. And if you have multiple bands, you can see their reproducibility is very well, very good. We also have developed a protocol to do the pencil stain. Nowadays, many labs would look at the protein transfer before they put it into Western blotting. And so this is one of the protocol we recently developed for eStain L1, which you can use the pencil stain to look at the membrane with your protein on there. And of course, you can do it manually. But then again, if you look at the eStain staining results, then it's actually much more pronounced and then much more consistent. Okay, for today's, so here I will just briefly summarize what we just talked about. And I think the key phrase here is that 3-hour Western blot is actually a reality. And so this is helped by a number of things, and of which the EasyWest Lite helps us to automate the incubation steps. eBlot L1, so the only fast wet transfer device that's on the market and can help us to make the transfer just as efficient as the wet transfer, but much faster. And then we also have the SurePage gel. It's a high quality and high resolution precast gels that helps to cut down the electrophoresis time. And last but not least, the eStain L1 would help us in the middle to, if we want to do either the total protein quantitation, then we can use the pencil stain to stain the membrane and then take the total protein from that result. So with that, and now thank you to attend today's webinar, and I'll be happy to answer any of the questions you might have on either the Western blot process or the any of the devices I've mentioned here. So thank you.